Hello, and welcome to my talk, Detecting Detectors in Open Source Packages, the New Frontier. First, let me introduce myself. My name is Tzachi Zorenstain. I'm the head of software supply chain at Checkmarx. Before joining Checkmarx, I used to work as a system architect at McAfee, as a threat analyst, tracking down advanced threat actor groups at Symantec and Palo Alto. And then I founded Dustico, a company which is focused about detecting attackers in code packages before being acquired by Checkmarx. So what are we talking about today? We're talking about open source. And the reason we are talking about open source is that open source is great. Open source is used by everyone. It helps us develop our product faster. Anybody can contribute code to an open source project, which is why it is so successful as an ecosystem, why it's moving fast so rapidly. But we ask ourselves, do attackers contribute code as well? The short answer for that is yes. Unfortunately, they do. And we are seeing a huge surge in number of supply chain attacks on the rise, targeting open source packages. In this lecture, I would like to share some of the recent trends that we are seeing and give a couple of advices how to avoid these new attackers trying to poison the open source packages, and by them poisoning my code base, jeopardizing my company and my customers. So, as I said before, let's talk about a couple of open source supply chain incidents we've seen recently. Let's talk with a really interesting one called the UA parser. So a lot of time we believe that if we will use a well-respected, well-maintained open source package, nothing bad will happen to us. Many eyes guaranteed security. Oh, that's what we think to ourselves. There will be no malware or no vulnerability there. Unfortunately, this isn't necessarily the case. So let's give an example of a good package gone bad. Our story begins when a package named UA parser, which is, by the way, a well-maintained package. It's been around for 10 years. It has more than 8 million weekly downloads. You would probably approve your developer team or yourself to use this package until a malicious version was released to the internet. The malicious version contained the normal functionality, but added another piece of code. The first line of code that you see in red, it's what we call a password stealer. It actually tries to download and steal like every password on your developer computer or your customer computer, if you actually use it inside your product. The second line of code downloads what we call a crypto miner, which is a piece of malware who is trying to use your computer resource to mine crypto coins. In this case, if I remember correctly, Monroe. So this affected a lot of organizations. And it was so severe that CISA actually published a report, an alert saying a newly discovered malware in popular package, UA parser. If you were using this version, you were affected. You need to replace all your passwords. You need to alert your customers, and so on and so on. Unfortunately, this wasn't the only incident. 2 weeks later, 2 highly popular, highly maintained, different NPM packages were also affected. The packages COA and RC. And they were affected in a way that suddenly a new release was published by these packages. And this release actually contained the same malicious tools, the same crypto miner, the same password stealer that we saw in UA parser. Do you think it's a mistake? Do you think it's a coincidence? The sad truth is this is not. This is actually an attacker. And we track this attacker as UNC 3379. And looking at all his activity, my research team at Checkmarx was able to track that even before he did the first attack on UA parser, he did what we call the dry run. He actually uploaded 3 packages, Oksha, Clo, and Clone, with the same README of UA parser, but without the malicious payload, just doing just activating a calc to make sure that his code is running. And after he saw that his code is running, he actually took and did the same attack on the real account, on the new UA parser. Fortunately for us, he didn't do a dry run when he attacked Koa and RC, and he had a bug. We were the first to detect that and report on that bug. And luckily for us, he only broke the packages and broke the builds and didn't compromise the builds. So how come he was able to do all that damage? You need to remember, when we are talking about attackers, we are changing the terminology. We are not talking about vulnerability, mistake, logic, flaw. We are talking about tools, techniques, and procedures. Understanding that, you can see by the comment of the contributor of UA parser saying, guys, somebody hijacked my account and he used my credential to publish these compromised packages. This is a kind of attack we call account takeover. And apparently, this attacker did the same thing to other contributors, again, posting again and again malicious versions, affecting a lot of organization. So what can we do to protect ourselves? So first of all, we need to remember that this is a malicious problem. This is not a vulnerable problem. So we can't deal it as something that someday it will be tracked as vulnerable, and then we can decide if we wanted to use it or not. We need a different kind of mechanism. I encourage you to go out and check Chain Alert, which is an open source tool we actually developed to detect account takeovers, such as these. And it's built around malicious intent, not around vulnerable code or buffer overflow, SQL injection, and such. So this was the first example of a good package going bad. And I'm guessing that we will see more and more on those attacks. But this year, we actually saw something new. Meet Brandon Notsky Miller. So Brandon is is an active and well-known open source contributor. He has more than 41 different projects. He's trying to making a positive impact, which is great. He has one package called Node IPC, which is quite popular. And when we look at Node IPC, we can see it's being maintained for 8 years, which is great. All the issues are being cracked and resolved. And we can see that it has more than 1 million weekly downloads, which is a lot, meaning that because of the number of weekly downloads, even if you think you're not using Node IPC, there is a good chance a package that you are using is using a package that's using a package that's using a package that's using Node IPC. So what happened to Node IPC? This year, a couple of months ago, Brandon added a new functionality. And if we look at the functionality, we can see it's a bit strange because you can't necessarily understand what's written inside the code. Beautifying the code, we can actually see that he's actually doing a couple of things. The first thing he's doing is reaching out to a URL called API geolocation. And as you can guess by the name, when you reach out to that URL, you get in response the country that your code is running on. So first, he wants to determine which country his code or his package is running on. The second thing that he is doing is actually checking if this country is in Russia or Belarus. If the answer for that is yes, then you don't need to be a programmer to understand what's written there. Basically, he tried to wipe or delete every file on your computer. This is the end result. He actually changed all the files to a art emoji and trying to hurt every computer inside Russia and Belarus. So why would this contributor, which has been so active, so positive, such long, do such a thing? Can you guess? Write your answers in the Q&A. So the reason for that is quite simple. Brandon lives in Ukraine. and he decided to do that in a protest against the war. Actually takes full credibility, full accountability for what he does. He actually wrote on his social media, "You download my software for free, so I'm allowed to wipe your computer." And he actually described it as a protestware, which is now a term, a new point, protestware, using open source to hurt other people, not for profit, but to make a political stand, which is a very alarming trend, mixing up politics and open source. So the industry really didn't like what he was doing, and he got a lot of backlash. People were saying, "Thank you for teaching me not to take handouts and code for everybody else without verifying." This is basically what we are saying. Don't take code from strangers without verifying it first. So this kind of protestware, again, wasn't an isolated incident. My team at Software Supply Chain Security at Checkmarx actually detected a couple of more protestware. And we are aware that more and more of those attacks will be coming forward. An interesting question that raised in this issue is, what do we do with these other projects? Do we automatically ban them, use them? I have to say they are perfectly clean. There is no vulnerability, there is no code, there is no malicious intent. But right now you are relying on somebody that has showed that maybe is not as reliable as we would like to think. Should we track that? What is your policy around that? Again, this is not the same area that we used to be in, talking about vulnerable. So for me, vulnerable is the possibility that something can happen. Like, as you see in the diagram before you, a vulnerable package, an attacker can get in, maybe will do some damage. And then I need to do risk assessment. Is that something that I want to prioritize, or how to deal with? Now when we are starting to talk about malicious intent and malicious actions, it's a whole different ballgame. We are actually tracking and seeing the malicious payload inside the package. And there is no logical flow. So I'm not sure that you are aware of that, but vulnerable malicious packages are not tracked as CVEs. They are most of the time just removed. Sometimes they are tagged as security holdings, but there is no clear indication if one of the packages that you are using right now was actually flagged as malicious files. So again, good package gone bad for different reasons. But this isn't the only use case that we are seeing. We are actually seeing attackers trying to poison more and more open source packages to trick the developers. One of the more interesting attackers we've seen recently is an attacker we tracked under Red Lily. So in the past, we used to see an attacker publish a couple of packages and to see if he catches something. But what we've seen recently is a huge surge in the sophistication of those attackers. So let me give you a couple of examples. First of all, what Red Lily attack group has done is built a full infrastructure to launch attack at scale. So they build a full infrastructure to create fake user account, to bypass two-factor authentication, to set up an email domain, to get the challenge response from the email, automatically push it into the publish. So they are able to do the same attack, but at a much larger scale. They are trying to trick developers by using stolen package description. Every time, again, as part of the automation, they will use a different description. They are adding evasive code, meaning they are checking that their code isn't running on some kind of a monitoring system. So they do their own homework and they study like every scanner that is out there and trying to catch them, and they add code saying, if this scanner is watching my code, don't run. So again, they came prepared and they're actually adding more and more evasive code. And in order to be unique, they're actually using an open source tool called Intercache to set up their own custom domain. So there isn't just one domain you can block. So they are using multiple domains. And a lot of time they will use SSL encryption, so the traffic will not be easily visible. Again, every time a developer is tricked into downloading one of those packages, his SSH keys, his system environments will be stolen, which is a great damage to the company. So creating a user account per package by defeating the two-factor validation, which is quite cute. And we really believe in giving back to the community. So everything that we found, we constantly disclose again and again and again into NPM. With Red Lily, the amount was such huge that we actually started a tracker site, which I encourage you to go and look, redlily.info. In there, you can see every package, every username, every C2. Unfortunately, there are a couple of those packages still active even after we disclose them. So I encourage you to go out and check redlily.info. Let me show you the website. I hope you can still see my screen. One moment. I always prefer to show like a live demo with not just the slides. So if you can see my screen, this is redlily.info. And you can see all the packages that are tracked. On a package, you can see, if you click on it, when it was published, what was the version, what was the C2, what was the username, what code that it had actually contained, what it tried to do. And we actually are giving researchers the sample evidence to check them by themselves. As I said before, some of those packages are still active, so be aware. And you can actually go and look at specific packages, which is what I'm showing you right now. And you can actually go and see that for a specific package, what were the connections between the usernames and the C2s and the package names. So Red Lily is really one of the most sophisticated attackers that we have seen. Don't be like that. Don't go there and don't blow this off. Just a couple of the names of the packages he published after we started disclosing all of his packages. You can think of it as a message in a battle to us, but I really encourage you to go to redlily.info and inform yourself. So what are my key takeaways? Because I want to have some time for Q&A. So attacks on open source are real. Don't believe that if you're using a well-popular, well-maintained package, you're in the clear. You always need to protect and be aware of what's happening outside, because attackers are there and they are hunting for us. We really believe in using open source to secure open source. So I would encourage you to go to the GitHub of Checkmarx and check Chain Alert, a tool we developed for open source project to detect account takeover and protosware. Dusty Law against dependency confusion, chain jacking against repo jacking. And of course, there are other great tools out there like OpenSSF Scorecard. So as we always say, don't take code from stranger, verify the reference. I hope you found this talk interesting and you were able to learn something. Feel free to reach out to us in social media if you need more information or you want the samples, because attackers are coming for us, and all of us need to work together to keep the open source, the open source ecosystem clean and safe for everyone. Thank you very much, guys. Be happy to answer every question that you have.